Got to use the microphone this time. Okay. So to start with, we need a little bit of an explanation about the title. It's a little misleading to a point, but this is a presentation we originally gave earlier this year at Black Hat in Washington, D.C. And the title was marginally clever, so we decided to stick with it. But it's really not just about serialized GUI objects. To give you a little bit of a background as to why we started doing this research, we were working on an application penetration test, and it was written in Java server faces. Well, Java server faces is something we'd heard of, but we really hadn't done a lot of research on it. So we decided to start doing a deeper dive, created some applications of our own, started looking through the source code, and discovered a flaw that very closely matches the title. It had to do with serialized GUI objects. But then it occurred to us that, maybe there's actually some vulnerabilities in other frameworks as well. We started looking at .NET in particular and saw a closely related vulnerability that uses a very similar technique, but it doesn't have to do with serialized GUI objects. So might be a little more accurate to say it's about view states, but we couldn't come up with anything catchy. So to start off with, we'll have some definitions. We're going to talk a little bit about some of the things we were thinking through when we first documented it in terms of whether or not the vulnerability was an ODE. Go through some vendor documentation from 3 different vendors that were involved with this that led to the vulnerability being more severe than it really needed to be. We're going to provide a live demonstration first with Apache MyFaces, and then also sort of explain at a lower level why it was happening, and then show the related vulnerability in ASP.NET and also look at some source code there. And then finally, if we haven't been kicked off yet because of running out of time, we'll talk about some recommendations.
Okay, so web pages nowadays tend to be highly dynamic. So instead of request, response, where there's response is sent back to a different page, web pages now issue postbacks. So if a user selecting a country from a drop-down might trigger a postback to populate the states for that country. So as a consequence of postbacks, applications now need to remember the state of the GUI controls on that page. And the mechanism they use to do that is called the view state mechanism, so view of the state. And the implementations of view state are done differently by different frameworks. So Java server faces will store the entire UI component hierarchy in the view state and the state of every component. While .NET just stores the changes that have been done to each control programmatically. And the control hierarchy is actually stored on the server. So view state tampering. There's a number of ways you can tamper, and that's really the gist of our presentation is how can you attack view states. So you can do a number of things. You can embed malicious data in client-side view states where the server will render the attack in its response. And the data can be client-side code or limited server-side code, and we'll show demonstrations of both these attacks.
So there's 3 frameworks that are affected by this. 2 of them are implementations of the Java server faces standard. It's a standard that was formalized by Sun, but they didn't actually implement it. There's as a direct part of Java. There's 2 main implementations. One of them is Apache MyFaces, where we made the original discovery of the vulnerability. And then the second one is Sun Mohara, which is a implementation of the same standard. So basically, if you're a Java developer, the standard is pretty much interfaces. And the only thing that's part of the Java distribution is the interface of MyFaces. Apache MyFaces and Sun Mohara both implement the same set of interfaces, but from a code point of view, they're completely separate. Because of the way they've implemented view state, though, they're both vulnerable to effectively the same attack. The actual the code has to be a little bit different just because there's some slight differences in how they generate the view state, but fundamentally it's the same. For Microsoft, it's basically, well, the demonstration we're going to be doing should have been with 3.5, but I'll just say this right now. We gave this presentation in DC, and one of my responsibilities was to keep track of the virtual machine that we were using for the demo. And last night, about midnight, I realized that at some point in the last couple of weeks, probably, I deleted it. So I spent from about midnight to 1:30 in the morning recreating our VM. Fortunately, I had all the important code, but I wasn't able to get ASP.NET 3.5 on there, which is weird because it's server 2008. But anyway, the code is going to be virtually identical, and if you don't trust me, I can show you how to set it up on 3.5. One of the things that we were sort of pondering internally at TrustWave when we first came across this is this an O-Day? You know, on the one hand, nobody had ever really documented an attack quite like this. So it certainly had that component of being an O-Day. But on the other hand, there were some existing configuration options that could make the attack impractical or impossible by securing the view state. After some internal debate, we kind of realized that the best analogy is to compare this to WEP. I think most people here are probably familiar with WEP as, wired equivalency protocol. When it was first released, it was known to use weak encryption, but there were no practical attacks against it. So no one was really surprised when in 2001, several years after it was released, someone came up with a practical attack against the algorithm, and then later that year, the AirSnort was released, and WEP has been completely broken since then. But even though it was anticipated, just because AirSnort was fulfilling something that had been anticipated before, it was still really was an O-Day in the vulnerabilities that researchers before had documented. WEP is still available on access points today. We do at TrustWave, we do wireless assessments. We see WEP all the time. There was no patch that was released for WEP. The solution is really configuration. Move to WPA, move to other stronger forms of encryption. And that really applies to this as well, the vulnerabilities we'll be talking about. They have been predicted before, but as far as we could tell, with one very small caveat that we'll get to in a little bit, no one ever actually launched this type of attack against view states. So as I mentioned earlier, part of the problem that sort of led to this being more severe than it needed to be was poor documentation by the vendors. When I was preparing the presentation, or when Rohini and I were preparing it, I was looking at in detail at some more of the documentation from the vendors. For example, this is from Sun and their FAQ for Sun Mohara. One of the questions is, how can I secure view state when using client-side state saving? It's a very important question. The answer is, by default, view state will not be encrypted. However, there's a way to do this within Mohara, and then it gives you examples of how to do it. Nowhere in there does it say, if you don't encrypt the view state, you're going to be in a lot of trouble because you're going to be allowing the attackers access to all kinds of stuff. So Sun wasn't wrong, but they didn't really give very good advice either. The advice should be that you always secure view state. Apache gives a fairly poor recommendation, or at least used to. They said one consequence of client-side state saving is that anyone with a decoder and some time to kill can reconstruct the UI object model on the client side. This can be a problem for those of us who make use of the excellent T-save state tag. Now, I found this sort of marginally offensive because it kind of implied that anyone with a decoder and some time to kill maybe didn't have better things to do. That's exactly what we wrote, was a decoder. I'd like to think that it wasn't because we just had too much time on our hands, that it was a good use of our time. But it's also bad advice because it implies that it's only a problem if you're using T-save state tags, which is not true. Virtually any application written in using MyFace or Sun Mohara is going to be vulnerable to significant attacks with just the most common of controls that pretty much any application is going to be using. Microsoft is a bit of a mixed bag. Microsoft has huge amounts of documentation, so it's not very surprising that some of it's a little contradictory. When they're talking about the security used to save the view state, at one point, several points in their website, they say, do not set this property to true if performance is a key consideration. That is sort of true. It does take more CPU cycles to cryptographically sign something, but I suspect that this was written probably when .NET first came out back in 2000. 10 years later, CPUs are a lot faster. The amount of encryption to secure view state is trivial, and while it may be measurable on certain types of environments, it still isn't an option. It's not something that you can just disable to save a few CPU cycles. In order to have a secure application, it is critical that the view state be signed. They also make some recommendations that are good but not very specific. For example, they say by creating a hash value, the ASP.NET page framework can test whether the view state data has been corrupted or tampered with. That's their